Assalamualaikum and salam sejahtera. Okay class, for this video we are still in chapter 8, which is measures of dispersion for ungrouped data. So let's look at our first learning objective in this video, which is explain the advantages and disadvantages of various measures of dispersion to describe ungrouped data. Okay, let's look at the color highlight here. Look at the first one. Okay, but before that, to recall back your previous lesson, okay, you already know, right? There is a few types of measure of dispersion. There is four types, which is the first one is range. The second one is interquartile range. The third one is variance, and the last one is standard deviation. So, what is the advantages and disadvantages of these four types of measures of dispersion? So, in this learning objective, we are going to learn the advantages and disadvantages of these four types of measures of dispersion. Okay, let's look at the first one, range. Range is the measure of dispersion which is easiest to calculate. So among the four types of measure of dispersion, range is the most easiest one to calculate. Okay, and then however, you need to know that range cannot provide a good overview of how data is distributed. Okay, so look at the next one. Okay, when there is an outlier or extreme value, okay, what is outlier or what is extreme value? Okay, I will explain to you later, but let's go through this sentence first. Okay, if there is an outlier or extreme value, the interquartile range would be the more appropriate measure of dispersion to show the distributions of data. Okay, so it means that if the ungrouped data, if the least number of ungrouped data, there is an outlier or extreme value among the ungrouped data, so it means that interquartile range is the most appropriate way to measure dispersions of the distributions of data. Okay, let's look at the yellow one here. Okay, for standard deviation, it is usually used to compare two set of data. So, in general, low standard in general, a low standard deviation indicates that the data is dispersed close to the mean. So you need to remember that if the standard deviation value is low, so it means that the data is dispersed close to the mean. So if the data is dispersed close to the mean, so it means that the data is more consistent and more accurate. Okay, remember that one. And for if the standard deviation is high, so it indicates that the data is dispersed far from the mean. So what does it mean by dispersed far from the mean? So it means that it is not accurate and it is not consistent. Okay, remember that one. Okay, so let's look at example 10 here. Okay, if you can see example 10, okay, calculate the range and interquartile range of the set of data 10, 11, 11, 14, 18, 20, 21, 21, 25, and 40. Okay, as you know before this, you already know the terms outlier or extreme value. So this is what it means by outlier or extreme value. This one, this one, 40. This 40 is what we call as outlier or extreme value. Because of what? Because it is far away, or the value is far from the other data. For example, like this one, 10, 11, 11, 14, 18, 20, 21, 21, and 25. All of this is close to each other, but suddenly there is 40 here, which is far away from the other data. So it means that 40 is what we call as outlier or extreme value. Okay, now let's look at the next one here. Okay, so the example 10 asks you to determine the most appropriate measure of dispersion to be used to measure the distributions of the data. So in example 10, they ask you to determine which one is the most appropriate measure of dispersion. You already know there is four types of measure of dispersion, right? Which is range, interquartile range, variance, and also standard deviation. But if there is the outlier here, so it means that, as you can see, if there is an outlier or extreme value, so it means that interquartile range would be the more appropriate measure of dispersion. So in example 10, okay, you need to calculate first what is the range and what is the interquartile range based on the formula to find the range and interquartile range that you already learned in your previous lesson. But now let's focus to determine the most appropriate measure of this dispersion. So if you see the outlier or extreme value here, automatic you need to know that the most appropriate measure of dispersion is interquartile range. Interquartile range, okay? So let's look at here. The conclusion. Interquartile range is look at this one. This one, okay. Look at this one. Okay, interquartile range is the most appropriate measure of dispersion because the existence of the outlier, which is 40. That is how you do the question like this. Okay. Okay class, let's proceed with example 11. Okay, the table below shows the achievement of two pupils in 5 physics tests. One of the people will be selected to represent the school in a physics quiz competition. And then the question asks you to determine who is eligible to be selected and justify your answer. Who is eligible, which means that who is the most suitable one based on the data given here. Okay, so you need to justify your answer by calculation. Okay, but before that, let's look at our first that you have learned just now. Okay, look at the yellow highlight here. Okay, look at the one. Look at this one. Standard deviation is usually used to compare two sets of data. So the question here for 11, for example 11. Okay, which measure of dispersion that we need to use? Either range, interquartile range, variance, or standard deviation. So the answer is you need to use standard deviation in order for you to compare two set of data. So let's look at Aiman first. Aiman, you need to find the mean first. Because of what? Because in order for you to compare between Aiman and John, look at Aiman. Mean for Aiman is 69.8, and then mean marks for John is also 69.8. So how you want to select either one of these student? So you cannot select the student based on mean only, right? Because the mean for both student are the same. So what else you should do? Okay, the second one that you need to do is you need to calculate the standard deviation. Okay, this is the symbol for standard deviation. Okay, and then after you calculate the standard deviation based on the formula that you already learned in your previous lesson. Okay, so for Aiman, the standard deviation is 17.67, and then for John, the standard deviation for John is 7.574. Okay, let's look at the two standard deviation here between Aiman and John. So Aiman have a greater standard deviation compared to John. John have the small standard deviation. Okay, let's look back at our first learning. Okay, look at this one. Low standard deviation indicates that the data is dispersed close to the mean. So if the data dispersed close to the mean, so it means that the data is more accurate and then consistent. Compared to high standard deviation, it indicates that the data dispersed far from the mean. If it is far from the mean, so it means that the data is not consistent and not accurate. So which one that we need to choose to represent the school in a physics quiz competition based on standard deviation. Okay, I might have a bigger standard deviation, and then for John it have a small standard deviation. If standard deviation is small, so it is dispersed, the data is dispersed close to the mean. So your answer will be, determine who is eligible to be selected and justify your answer. So the answer is here. John will be selected to participate in the physics quiz competition. Justify your answer. So this is the answer for justification. Why? Because the standard deviation of John's score is lower, because John's achievement is more consistent. Okay, like this. This is how you choose the four types of measure of dispersion. Okay. Okay, I hope that you can understand. Okay, we done already for this one. Okay class, let's proceed with our next learning objective, which is construct and interpret the box plot for a set of ungrouped data. So, what is a box plot for a set of ungrouped data? Okay, as you can see, box plot is a way of showing the distributions of a set of data based on 5 values. Okay, this one. Namely, maximum value, first quartile, median, third quartile, and maximum value. Okay, so, okay, wait. Okay, now. Okay, and then what is the thing that you need to know is the box plot is often used to analyze a large number of data. Okay, a box plot is used to analyze a large number of data. Okay, now let's look at this one. This is some types of box plot, which is the first type is this is the Q1. Q1 represent the first quartile, Q3 represent the third quartile, and then M represent the median. Median also known as a second quartile. Okay, and then type 2. Okay, for this one, as you can see, median is exactly in the middle in between Q1 and Q3, midpoint. M is the midpoint between Q1 and Q3, and then if you can see type 2, M close to the Q1 as compared to Q3. Okay, this is another type of box plot, and then the third type of box plot is the median M close to the Q3, which is the third quartile. Okay, okay, so next look at this one. Okay, how do you construct a box plot? Okay, the box plot is construct on a number line. Okay, box plot, as for your information, box plot is construct on a number line. Okay, next let's look at this one. Okay, this is the data below shows the mark obtained by 15 people in a Chinese language test. So this is the result of the test. Okay, so in order for you to construct a box plot, you need to know what is the minimum value, first quartile. Okay, minimum value, first quartile. Okay, first quartile, median, third quartile, and maximum value. Okay, another information here. Okay, the box plot can also be constructed vertically. Okay, remember, if you see the box plot construct in vertically, so it means it is correct lah. So what should you do? Okay, remember, in order for you to draw a box plot, you need to identify first the minimum value, first quartile, median, third quartile, and also the maximum value. And then after you identify the value for each 5 of these, so then you can do the box plot. Okay, this is normally image of the box plot, which is horizontally. Okay, so And the first thing that you need to do is you need to draw a scale for this one and mark label with mark lah for this one, mark. So if the data given is week, so this one is week lah. Okay, after you draw the number line here, then you make a scale. So for this one, the suitable scale is 5. Okay, so 35, 40, 45, 50, 55, and so on. Okay, now, and then based on the 5 value that you already know, then you need to draw a dot. Okay, so the first one is minimum value. So 35, you need to do a dot here for minimum value, and then the first quartile is 45, then you need to draw a dot here, and then the median, so median is 57, so it is in here. Okay, and then you draw the dot, and then the third quartile is in here. Okay, and then the maximum value is 75 here, and then after you already draw the dot, and you need to connect. You need to do this one, the rectangle in shapes of this one that represent the interquartile range. Okay, so you need to draw this one, the rectangle shape here, and you need to do it like this and connect the interquartile range with the minimum value and also with the maximum value. And then after that, then you need to label with this one, minimum value, interquartile range, maximum value, Q3 and Q1, and this one. Okay, make sure you label, you need to label all the value, the 5 value. Okay, so and then after that, so let's look at here. Okay, example example 12, sorry. Okay, 2 box plot are given below. Okay, there is 2 box plot given, which is box plot A and box plot B. Okay, this is and then the question asks you, for each box plot state the median. So the median for A, where is the positions of median? So median is in here, inside the rectangular shape here. Okay, it is very easy. You just need to remember the label. So for this one, this dot represent the minimum value. This one represent first quartile. This one represent medium. This one represent third quartile, and this one represent maximum value. That's it. If you can remember all these dot represent as what, then you can answer this question. So for each box plot, state the median. Median for A, so median for A is here, right? So median for A is 52. Okay, and then median for B is this one, median for B is 11. Okay, 11, this one 11. Okay, and so on. And then for first quartile, then you need to know where is the dot for first quartile. Okay, that's it. It is very easy actually. Okay, okay, for median for B, the median is in here, right? And then the scale is 5. So 10, it will become this one, this scale will become 11. So median for B, it is 11. That's it. So you just need to remember, this one is the minimum value, this one is the maximum value, this one is first quartile, this one is third quartile, and this one is the median. That's it. And then the rectangle shape here, this one, what we call as a interquartile range. That's it. As long as you remember the label, then you can answer this question. Okay. Okay, let's look at the next our next learning objective. Okay, our next learning objective is determine the effect of data changes on dispersion based on the value of measure of dispersion. And then the second one is graphical representation. So let's look at the highlight here. Okay, the data changes include the following cases. This is the possible cases that will happen in the measures of dispersion. So A, each data is added or subtracted by a constant uniformly. B, each data is multiplied or divided by a constant uniformly. And C, the existence of outlier or extreme values in the set of data. And the last one, certain value are removed from the set of data or added into the set of data. Okay, let's look at A first. Okay, A first. What is the effect of measure dispersion when each data is changed by adding or subtracting a constant? Okay, look at this one, the case one, the first case. Okay, for example, initially I have a set of data 5, 8, 3, 4, and 1, and if each value of the set of data is added by 5, so means that you need 5 plus 5, 8 plus 5, 3 plus 5, 4 plus 5, and 1 plus 5. That is what we call as added by 5 for each value. Then the data above will become 10, 13, 8, 9, and 6. So what will happen to the measures of dispersion such as range, interquartile range, variance, and standard deviation for the new set of data? So it means that this one dia nak bagi tahu awak macam mana, okay, how jika ada satu value tu which is 5 ditambah pada data yang asal menjadi this one, menjadi this is the new value, this is the new set of data. So adakah range, interquartile range, variance, and standard deviation akan berubah juga? Macam akan berubah daripada yang original one. So let's look at the conclusion here. We go through into the conclusion. If you want to prove it, then you can do it on your own. Let's look at the conclusion. Okay, there are no changes. So if you added or subtract a data, or if you added or subtract a value constantly for each set of data, so it means that there are no changes to the measure of dispersion when each value of set of data is added or subtract by a constant. Okay, by a constant. Okay, remember, by a constant. Each value must be each value. For example, if the value in a set of data is added by 5 just in the first set of data sahaja, the second one, third one, fourth one, and fifth one you not added, so it is not applicable for this conclusion. You must add or subtract each value of set of data in order for you to use this conclusion. So it means that there are no changes to the measures of dispersion. Okay, so look at the next one. Okay, this is the situation. Initially I have a set of data 5, 8, 3, 4, 1. Okay, this case, if each value of the set of data is multiplied by 2, then the data above will be 10, 16, 6, 8, and 2. So what will happen to the measures of dispersion such as range, interquartile range, variance, and standard deviation for a new set of data? It's not multiply only, divided also applicable in this one. Okay, let's look at the conclusion. Okay, so look at the conclusion. When each value of set of data is multiplied by a constant mean by a number, which is 1, 2, 3, 4, it is not include unknown. If it is multiplied by 2x, so it is this conclusion is not applicable for this one. Alright, let's do continue. Okay, if each of set of data is multiplied by a constant k, then the range, interquartile range, standard deviation, and variance will be changes. How it changes? You need to multiply with the constant, or you need to divide by a constant. Okay, for this one, multiply by k. So the new range is k multiply with original range, and then new interquartile range k multiply with original interquartile range. Okay, and so on. Same goes as for division. Okay, if divide by 5, so the new range you need to is equal to original range divide by the division that given. Okay, so this one also, and also for new variance. Okay, but for variance it's a bit different. You need to power with 2, or you need to square the division value. You need to square. Same goes as this one. If multiply, so k must be k square, and if division, k must be k square. Okay, That is the difference for variance only. Okay. Okay. Okay, class. Now, we go to the next one. Okay, what are the effect on the measures of dispersion when an outlier is added or removed from the set of data? Okay, outlier or extreme value is added or removed from the set of data. So what will happen to range? Range will change dramatically. Okay, and then interquartile range also will be changed, which is the interquartile range is less affected. Okay, and then variance and standard deviation. Okay, for variance and standard deviation, it will increase significantly. Okay, when outlier is added into the set of data. Okay, and then if the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. Okay, if the difference between the new value of the data, it means that the outlier is added and the mean is small, the new standard deviation will be smaller and vice versa. And then if the difference between the value that is removed and the mean is small, so it means that the new standard deviation will be larger and vice versa. Okay, so let's look at the next one. Okay, now look at here. The effect of data changes can be graphically displayed by using dot plot, stem and leaf plot, or box plot. So look at A. The data is changed uniformly by adding or subtracting a constant. Okay, look at this is the original data. Okay, this is the original data. Okay, when each value of a set of data is added by 2. If it is added by 2, this is the original data, and if it is added by 2, so 8 plus 2, you will get 10. And then this one, 9 plus 2, you will get 11. This one, 11, 11. And then 10 plus 2, you will get 12, like this. So this is the whole graph. This is the whole graph, the dot plot. Okay. Okay, so if as you can see in the above diagram, when each value of a set of data is added by 2, so it is found that the whole dot plot is shift to the right by 2 unit, where the dispersion remain unchanged. The dispersion remain unchanged, but the whole dot plot will be shift to the right by 2 unit because of what? Because it is added by 2. Same goes as when each value of set of data is subtract by 2. If it is subtract by 2, so it means that the whole dot plot is shift to the left by 2 unit, and then the dispersion remain unchanged. Okay, let's look at the second one. How about the range? Okay, as you can see, I hope that you can still remember just now. I told you that if a set of data is added or subtract uniformly in each set of data, so there is no changes for the measures of dispersion. So if it is added by 2, so it means that range is not changing anything. Let's look at this one. Look at the original one. The original score range is 7. And then the new score range after added by 2, still you got 7. So it means that the range is unchanged. Okay? Okay, so look at the in general. When each value of a set of data is added by a constant, the measure of dispersion remain unchanged. Okay, remember, just the position. The whole dot plot will be shift to the right by 2 unit. That's it. This is the only difference lah. Okay, but the dispersion remain unchanged. Okay, I hope that you can remember. Okay, what happened when the data is changed uniformly by multiplying or dividing by a constant. Okay, let's look at this one. This is the original data. Okay, and then what will happen when each value of a set of data is multiplied by 2? So 1 multiplied by 2, you get 2, and then 2 multiplied by 2, you get 4, this one. And then 3 multiplied by 2, you got 6. 4 multiplied by 2, you got 8 here. And then 5 multiplied by 2, you got 10 here. Okay, so this is how the dot plot is. And then you can see that in the above diagram, when each value of a set of data is multiplied by 2, it is found that the dispersion of the whole dot plot become twice as wide. Okay, dispersion of the dot plot. Okay, wait. Dispersion of the dot plot will become twice. The dispersion of the whole dot plot become twice as wide. Okay. Alright. Okay. So what happened to the range? Okay. You need to recall back before this. Okay, what will happen when the data is multiplied or divide uniformly? Okay, I will recall back. Okay, wait, multiply. Okay, this one. When each value of a set of data is multiplied by constant k, so new range will become k multiplied with original range, and then new interquartile range k multiplied with original interquartile range. Okay, remember this one and look at our recent lesson. Okay, alright, this one. Okay, so wait, is it correct? Okay, multiply by 2, right? This is the 2 is k. Okay, 2 is k. Original score is 4. So in order for you to get new range, you need to 4 multiply with 2, which is the unknown k. So 4 multiplied by 2, you got 10. Correct, right? The conclusion just now. Okay. So look at this one. This is okay. The range of the new set of data is 2 times the range of the original set of data. So when each value of a set of data is multiplied by a constant k, so new range is equal to k multiplied with original range. So this is the same thing I told you just now. So just ignore. Okay. Look at the next one. What happened when the value added or removed is an outlier? Okay, this is the score. This is the original one. Okay, and then look at this one. When an outlier 9 is added, this is the outlier, the red dot here. Okay, what will happen when the outlier is added? So look at this one. In the above diagram, when an outlier is added to a set of data, it is found that the dispersion of the whole dot plot become wider. Dispersion of the whole dot plot become wider. So from this one, from dispersion from 1 until 5 only, it will become wider from 1 until 9. Okay, I hope you can see this one. From 1, bring it upright, and then until 9. And then as compared to the original one, the dispersion is from 1 until 5 only. Alright, okay, so it become wider. Okay, so the original score range, as you can see, the original score for range is 5 minus 1, you got 4, and then new score range 9 minus 1, you got 8. So the range of the new set of data become larger compared to the range of the original set of data when an outlier is added. Okay, so look at the general conclusion here. The measure of dispersion of the new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. So, okay, wait. Okay, and then what happened? Okay, this is the not care about question, just a simple question. In order for you to think a bit further, okay, what will happen when the outlier is removed? So what will happen? Okay, in case this one, if the outlier is removed, so the dispersion of the whole dot plot become narrow. Okay, become narrow lah. Narrow ataupun dalam bahasa Inggeris dia apa yang sesuai? Cikgu tahu narrow je. Okay, the dispersion of the whole dot plot become narrow lah. And then the score from the original one 4, and then the new score if this one the outlier is removed, so the new score will become the new score of range will become smaller. Okay, the range of the new set of data becomes smaller lah as compared to the range of the original set of data when an outlier is removed. This is the case if the outlier is removed. Okay, so look at the example 13. Okay, look at example 13. Given a set of data 4, 6, 7, 7, 9, 11, 12, 12, calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when 4 is removed. 4 is removed. Okay, but before that, you need to find out first the original for standard deviation lah. Okay, for original standard deviation, and then but before that, make sure you calculate first mean and standard deviation. Okay, why we need to calculate mean? Because it is easier for you to calculate standard deviation later. Okay, mean as usual, you calculate mean based on the formula that you already learned. Okay, and then you use the formula that you already learned, then you will get the answer for standard deviation is 2.784. Okay, this is the original. This is the original before we proceed with A, B, and C. This is the original mean and original standard deviation. Okay, class, let's look at here. Okay, new mean. Okay, if 4 is removed, if 4 is removed, so the new mean is 9.143. Okay, the new mean, and then new standard deviation. The new standard deviation is 2.356. Okay, 2.356. Okay, so when the value that has a greater difference from the mean is removed, the new standard deviation will be smaller. Okay, class. For A, the new mean is 9.143, and then the new standard deviation is 2.356. Okay, so from this one, okay, as you can see, for A, 4 is removed, right? 4 is removed. Okay, this one, when the value that has a greater difference from mean is removed, the new standard deviation will be smaller. So how come this one? How come the conclusion? How come the example 13 create this conclusion? Okay, let's look back at our previous lesson. This one, I already told you. Okay. When the difference between the new value, which one? Small. Okay, if the difference between the value that is removed and the mean is small, so the new standard deviation will be larger. Okay, maksudnya dekat sini perbezaan antara nilai yang dibuang dengan mean tu kecil. Jika perbezaan antara nilai yang dibuang dengan mean tu kecil, so maksudnya standard deviation new standard deviation akan menjadi besar. Okay, let's ingat benda tu. Okay, and then kita pergi pada example tadi. Okay, look at A. Okay, 4 is removed, right? 4 is removed. 4 and 4 and 8. Okay, 4 dan 8. Kejap, before that, tengok balik. Cikgu ingatkan awak semula. Okay, if the difference between the value that is removed and the mean is small, okay, then the new standard deviation will be larger. Okay, and then look at here. Okay, so this one A. 4 is removed, right? 4 and mean beza dia berapa? More than half, right? So it means that the difference between 4 dan juga mean adalah besar. So kalau besar, perbezaan tu besar, so apa akan berlaku? Tengok this one. Tengok this one. Okay. Bila perbezaan besar, bila perbezaan kecil, standard deviation akan besar. Tapi bila perbezaan besar, so standard deviation akan jadi kecil. So tengok this one. Okay, tengok A. Okay, bila perbezaan besar, which is 4 is removed, so perbezaan dia besar dengan mean yang asal, betul tak? So bila perbezaan dia besar, so it means that new standard deviation akan kecil kecil lah berbanding dengan original standard deviation. Nampak tak? This is dia nak prove kat awak lah about regarding to the conclusion dekat atas tadi. Okay, I hope you can understand. Okay, this is why the conclusion happened here. Okay, so when the value that has a greater difference from mean is removed, so the new standard deviation will be smaller than the original standard deviation. Okay, so look at the B pula. B, what happened to B? B, 7 is added. 7 is added. Okay, look at what you have learned kat sini. Okay, when added okay, look at this one. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller. Okay, bila perbezaan antara nilai baru bagi data dan juga mean tu kecil, perbezaan antara nilai baru yang dimasukkan dengan purata adalah kecil, so our new standard deviation will become smaller. Okay, remember that one, and we go through the example 13. Okay, example 13. Where is example 13? Okay, B. Okay, 7 is added. 7 is added. 7 is added. And then when 7 is added, nampak tak perbezaan antara 7 yang ditambah dengan mean original dia, perbezaan adalah smaller, right? Tak jauh beza, which is 1 point something sahaja. Okay, not 1 point, yes, 1 point something, 1.5 only. Perbezaan dia hanya 1.5 sahaja. So it means that, so the difference is small. So if the difference is small, so the standard deviation will be, the new standard deviation will be smaller. So this is the proof. Okay, the new standard deviation from the original one. So from 2.784, it will become 2.668. Will become smaller. Okay. Okay, I hope you can relate because I need to roll dekat atas dan ke bawah. So I hope you can understand. Alright, 4. Look at C. 18 is added. 18 is added. So 18 is added. 18 is added. So 18 dengan perbezaan antara value 18 dengan purata mean 8, perbezaan dia besar, right? It's a large difference. So kalau perbezaan besar, so it means that new standard deviation akan besar. Nampak tak? Nampak tak this one? This is the proof. New standard deviation kita akan besar lah from the original standard deviation, which is 2.784. Okay, so when the value that has a greater difference from the mean is added, so the new standard deviation will be larger. So that is how the conclusion is created based on this one. Based on yang dekat atas tadi yang awak dah belajar. Okay, this one. Okay, alright, the next one. What else? The next one, example 13 done already. Okay class, let's proceed with our next learning objective. Okay, second last. Okay, compare and interpret 2 or more sets of ungrouped data based on the appropriate measures of dispersion and hence make a conclusion. Okay, look at example 14. This is not important. You can read on your own. Okay, let's proceed with example 14. Okay, the table below shows the time taken by 20 employees in 2 factories to complete a job. Okay, this is time which is in our factory A, factory B. Okay, calculate the mean and the standard deviation for the time taken to complete the job and hence determine which factory employees are more efficient to complete the job and justify your answer. Okay, so the question asks you to calculate mean and standard deviation and then determine which factory employees are more efficient to complete the job. Justify your answer. So you need to calculate first lah the mean for factory A and standard deviation for factory A. And then after you calculate, this is the result and this is the result. And then for factory B, 7.1 at the mean, and standard deviation for factory B, 1.044. So mean is just the same, so we cannot determine which factory that is more efficient based on mean only. You need to look at the standard deviation. Okay, remember just now our first lesson in this video is, if the standard deviation is small, then the data is dispersed close to the mean, and if the standard deviation is large, so it means that the data is dispersed far from the mean. So which one is that we need? So we need the standard deviation that is smaller, so that the data is dispersed close to the mean. So which one is the smaller standard deviation, factory A or factory B? So as you can see, factory B. Okay, so the answer will be the employees in factory B are more efficient because its standard deviation is smaller. That's it. That is how you answer this question. Okay. So we done already for this one, and let's look at our last learning objective, which is to solve problems involving measures of dispersion. Okay. Example 15, the table below shows the information of the masses of two groups of people. Okay, group A and B. And then there is the number of peoples here and the mean and also variance given. Okay, so what is the question asked you? All the people from group A and group B are combined. Okay, and determine the standard deviations of the mass of the combined group peoples. Okay. The question asks you to determine the standard deviations of the mass of the combined group of peoples. Okay, class. Now, the question asks you to determine the standard deviation of the mass of the combined group of peoples. So this is the only information given. Okay. And then, okay, what should you do? You need to know that in order for you to determine the standard deviation, you need to find what? Look at this one. Okay, look at this one. You need to find we look at the last formula, this one. Okay, you need to find the x square and what is it? Okay, wait, is it the right? Okay, class. Sorry. I explain again. Okay, the question asks you to determine the standard deviation of the mass, right? Of the mass of the combined group of people. Okay, so in order for you to find the standard deviation of the mass of the combined group A and B, so what should you do? Okay, you need to find this one first. Okay. Sorry, okay, you need to do this one first. Just now this one formula ni tak boleh pakai sebab ada frequency. This one also cannot be used, and this one can be used, but this is the most easiest formula lah for you to use. Okay, so in order for you to find the standard deviation, you need to find first what is the x square, total sums of x square. Okay, and then the mean. And then this one mean okay, so we need to find the x lah, the total sums of x square and also x. Okay, so x, what is x? X is the total value of mass. Total value of mass between group A and of group A and group B. So we need based on the mean here. Based on mean given, we can find the total sum or total value of mass of peoples. Okay, from this one, from mean. So this is the formula for mean, and you already know the formula for mean is this one, and you already know the value of mean is 52. So 52 is equal to this one. We don't know the value of this one. This is the value that we need to find, and then divide by n. N is the total number of peoples, which is 18. Okay, and then 18 multiply with 52, then you will get the answer is, for the sum of x is equal to 936. Okay, we done already for this one. We done already this one. Okay, wait. We done already for this one. Okay, now look at B, group B. This is the same thing. You need to do the same thing as group A, and you will get the total sum of x is this one. Total sum of x is equal to 672. Okay, and then after that, you need to find x square, total sum of x square. So how you want to find? You need to find based on the variant given. Okay, for group A, the variance, the formula for variance is this one, and then you already know the value of variance, which is 2.5. 2.5 is equal to total sums of x square over 18 minus with this one. This is the mean, which is 52 square. Then you will get the answer this one. Alright, okay, after you get the answer this one, done already for group A. Now same goes you need to do for group B, and this is the result for total sums of x square. And then after you already got got all this value, then you need to find the total sums of x is equal to, for group A, 936 plus with 672. Then you will get the total 1608. Okay, now done already for that one. Okay, and then the next one, total sums of x square is equal to this one for 48,717 plus with group B, and then you will got this one, this value. Okay, and then after you got this value, then you key in the formula of standard deviation, which is this one. Okay, this one, the second one here. Okay, and then after you key in, this is how you will get 86,700 370.6 divided by 30. 30 come from 18 plus 12. Okay, and then you got 30 minus with this one is mean, 53.6 square, this one 53.6. okay, and then you do it like this, and you will got the final answer is this one. So you already know that the new standard deviation is 2.462. okay, that's it. That is how you do it.